Greetings and welcome back to EDUC771, Analyzing Educational Research, Week 4. This week, we will discuss Chapter 4, Conceptualization and Measurement. Class announcements. I would like to thank everyone for submitting their comments to the Chapter 3 reflections. Job well done. Next, I would like to provide a few pieces of information regarding your research topic/questions. Remember, in Chapter 2, it mentions selecting a topic or question to research that is feasible, a topic you have the time and the resources available to pursue. This would apply to your action research and capstone, and also a topic with educational importance and or scientific relevance. I would highly recommend you peruse a few peer-reviewed articles of interest before you select a topic or question. Therefore, you can gauge the types of research completed on your topic and or question and formulate a question or topic after you have selected a few good articles to use in your literature review. Week 4 assignments. Watch Week 4 PowerPoint video. Complete Chapter 4 review problems. Complete Chapter 4 activity. Remember, the CITI course certification is due by October the 4th. Remember, the research resource assignment is due by October the 11th. I have copied the instructions to the research resource assignment to the Week 4 assignments folder. Complete Week 4 reflection. I will discuss this assignment towards the end of this video. This assignment is not in your syllabus. And finally, continue with your Chapter 5 textbook reading. In Chapter 4, we will discuss the measurement operations, level of measurement, and evaluating measures. Measurement operations. In educational research, we often try to identify variables we want to measure based on our questions, but we also want to make sure we achieve measurement validity. So measurement operations must actually measure variables we intend to measure. Thus, researchers develop indicators or items to measure certain constructs in their research. The 3 measures we will focus on in this chapter are measures based on using available data, asking questions, and or by making observations. Using available data. Government reports are rich and easily accessible sources of educational data. Educational evaluations and surveys are archived and made available to the public. For example, the National Assessment of Educational Progress, NAEP, which is the largest nationally representative and continuing assessment of what America's students know and can do in various subject areas. You should also consider appropriateness for concepts because all data may not fit well with a concept. Finally, don't assume accuracy. Sometimes data is measured differently in some studies versus others, like high school dropout rates, which may be measured differently across states, so data from various states cannot be compared unless you have ascertained the same methodology or instrument was utilized. Asking questions. asking questions a versatile operation for measuring educational variables can sometimes yield misleading or inappropriate answers. Must be screened, tested, and revised. Single questions are very popular. For example, you have closed-ended or fixed choice questions. These contain explicit response choices used when surveying large numbers of people, reduces ambiguity and makes the question easier for respondents to answer. Response questions should be mutually exclusive and exhaustive so that respondents can find only one choice that applies to him or her. In addition, you also have open-ended questions that do not contain explicit response choices and allow respondents to write in their answer choices. Researchers who study small groups use this type of questioning. Open-ended questions can allow for clear answers when questions involve complex concepts. You may utilize observations in your research as a primary form of measurement, or it can be used as supplement data in a study. Direct observation is a method of choice for measuring behaviors in natural settings, although measurement can be distorted because the presence of an observer may cause people to act differently from the way they would otherwise act. We will dive deeper into observation measures in Chapter 9. Triangulation uses two or more different measures of the same variable. The four measurement levels we will discuss in this chapter are nominal, ordinal, interval, and ratio levels. The nominal level is often called categorical or qualitative levels. It identifies variables whose values have no mathematical interpretation. They vary in kind or quality, but not in amount. Examples include race, sex, religion, marital status, and type of car owned. A variable's attributes or values are mutually exclusive if every case can have only one attribute. A variable's attributes or values are exhaustive when every case can be classified into one of the categories. Ordinal. A quantitative level of measurement is mutually exclusive and exhaustive. It represents only the relative position or order of cases. It measures rank order and scaling and provides greater or less than distinctions. For example, service quality rating or student letter grades. Interval measurements are fixed measurement units with no absolute 0 point. Indexes can be created utilizing this type of measurement. Differences between measurements can be added and subtracted, but contains no true zero. An example is reading temperature utilizing the Fahrenheit scale or standardized exam scores. Ratio level of measurement, which is the most mathematically precise, is a fixed measurement unit with an absolute 0 point. Height and age are examples of ratio level measurements. The chapter activity will allow you to practice more on identifying measurement levels. Types of measurement validity. Measurement validity refers to the extent to which measures indicate what they are intended to measure. Measurement validity can be assessed by 4 different approaches: face, content, criterion, and construct validity. Face validity establishes that the measure on its face seems like a good translation of the concept. This is considered a relatively weak way to demonstrate measurement validity. For instance, you might read through assessment questions that are intended to measure students' mathematical ability and decide that, yes, it seems like this is a good measure of mathematical ability. That is, the label mathematical ability seems appropriate for this measure. Or you might observe a teenage pregnancy prevention program and conclude that, yes, this is indeed a good teenage pregnancy prevention program. Of course, if this is all you do to assess face validity, it would clearly be weak evidence because it is essentially a subjective judgment call. But weak evidence doesn't always mean that it is wrong. Content validity. Content validity establishes that the measure covers the full range of a concept or established content in a field. Content validity is also an assessment of how well a set of scale items match with the relevant content of the construct that it is trying to measure. It may not always be possible to adequately assess content validity. As with face validity, you may need an expert panel of judges to examine constructs of content validity. Experts in a given performance domain generally judge content validity. For example, the content of the SAT subject tests is evaluated by committees made up of experts who ensure that each test covers content that matches all relevant subject matter in its academic discipline. Both a face validity and a curricular validity study may be used to establish the content validity of a test. We haven't spoken or will even go into curricular validity, but it means that the content of a test that is used to make a decision about whether a student receives a high school diploma should make sure it measures the curriculum that the student is taught in high school. Criterion validity. Criterion validity assesses whether a test reflects a certain set of abilities, that is, indicators or criteria of an outcome. The criterion that researchers collect can be measured either at the same time or close proximity as the variable to be validated or after that time. Concurrent validity exists when a measure yields scores that are closely related to scores on a criterion measured at the same time or within close proximity. Concurrent validity needs to be examined whenever one measure is substituted for another, such as allowing students to pass a test instead of taking a course. For example, a successful score on the CLIP college algebra exam may be used in place of taking a college algebra course. This measure is considered valid. So let's examine how this measure is validated. To determine the concurrent validity, students completing a college algebra course are administered the CLIP college algebra exam. If there is a strong relationship or correlation between the CLIP exam scores and course grades in college algebra, researchers conclude the test is valid for that use. Predictive validity involves testing a group of subjects for a certain ability or abilities and then comparing the results with results obtained in the future. For example, SAT scores are used to determine
whether a student will be successful in college. First year grade point average becomes the criterion for success.
Construct validity defines how well a test or experiment measures underlying theoretical constructs it is supposed to measure. A test designed to measure depression must only measure that, not similar conditions like anxiety. Construct validity is commonly used in social and educational research when no clear criterion exists for validation purposes. As an example, think about a general knowledge test of basic algebra. If a test is designed to assess knowledge of facts concerning rate, time, distance, and their interrelationship with one another, but test questions are phrased in long and complex reading passages, then perhaps reading skills are inadvertently being measured instead of factual knowledge of basic algebra. Construct validation requires the completion of multiple sources of evidence. In order to demonstrate construct validity, evidence that the test measures what it is supposed to measure, in this case, basic algebra, as well as evidence that the test does not measure irrelevant attributes, which is reading ability, are both required. These are referred to as convergent and discriminant validity. Convergent validity tests that constructs that are expected to be related are related. So in our example, convergent validity consists of providing evidence that two tests in mathematics that are believed to measure closely related skills or types of knowledge correlate strongly. This is to say, the two different tests end up ranking students similarly, whereas discriminant validity tests that constructs that should have no relationship do not have any relationship. Discriminant validity, by the same logic, consists of providing evidence that two tests in mathematics that do not measure closely related skills or types of knowledge do not correlate strongly. That is, dissimilar ranking of students.
The difference between reliability and validity. Reliability refers to the consistency or stability of a measure or test, whereas validity refers to the accuracy of the inferences or interpretations you make from the test scores. Reliability is a necessary but not sufficient condition for validity. That is, you can have reliability without validity, but in order to obtain validity, you must have reliability. So let's say we utilize a bull's eye to better understand reliability and validity. If I throw darts at the bull's eye and they are far from the center of the bull's eye, but they all land in the same proximity, my aim was reliable because I consistently hit the same spot over and over again. But my aim was not accurate or valid because I failed to hit the center of the bull's eye. Thus, I can have reliability without validity. Now let's say I practice for some time and I'm able to throw darts consistently in the center of the bull's eye. Now I have both validity and reliability. If I try once again, and this time my aim is unreliable because the darts land in different places on the bull's eye, then my aim must also be inaccurate and or not valid.
Different forms of reliability. Test retest is when researchers measure an unchanging phenomenon or consistency of a group's scores over time. Inter-item or internal consistency is when researchers use multiple items to measure a single concept. There must be consistency of items and measuring a single construct. Thus, coefficient alpha, an inter-item correlation, is usually calculated to ensure high association or correlation between items and what they are supposed to measure. Alternate forms reliability. When researchers compare subjects' answers to slightly different versions of survey questions, a researcher may reverse the order of the response choices in an index or modify the questions slightly and re-administer that index or questions to subjects. Inter-observer reliability is when researchers have various scores or observers rate the same people, events, or places, and there is consistency of agreement between raters.
Finally, you have reliability coefficient, which is a correlation coefficient that is used as an index of reliability. For example, you may read or hear in your studies a term called Cronbach alpha.
Week 4 Reflection. As an online community, I would like everyone in the class to introduce themselves. Please post the following: your name, what county or school you're currently assigned to, what subject or subjects you teach, what are your particular research interests, the number of years you have taught, and something about yourself you would like to share with the class.